LinkedIn echo chamber. This is ML's like Team Spirit. Today I've got Murray with me. Murray, how are you doing?
Oh, not bad. How are you doing, John?
I'm well. Murray, thanks for joining. Thank you for your support. Hey, Murray, I'm collecting a world map of my guests. Where are you, please?
Well, I'm in beautiful Czech Republic. That's where I live,
Great.
and that's where my wife and our family are from. Her family.
Super.
Yeah.
Well, look, I haven't got a pin in the Czech Republic map, so that's awesome. I knew you were going to bring me a new pin today, so thank you for that.
You're welcome.
Murray, I've been trying to get you to speak to me for a little while. Because you're a data scientist by background. We'll get you to introduce yourself in a moment. But you built something that's quite interesting, which is going to be the topic of today's call. So I think we'll do the intro first, if that's okay, and then leap into what you've created. So for about 60 seconds, could you introduce yourself to everyone and tell them what you've been doing?
Yeah, sure. Career-wise, is a data scientist. Been doing data science related things for retailers for over 15 years now. Usually like large retailers, sometimes international, often in the kind of grocery retail space. And I've done everything from analytics to building recommendation engines, looking at connecting retail data with advertising data and data monetization. So a little bit of everything, but a lot of it focused on analytics and personalization. But prior to that, I've been programming since I was about 6 years old. So I've had a lot of kind of experience with computers, built several hundred of them, worked in computer stores when I was to put myself through university. And I've built websites and lots of other kind of programming related things.
Well, Murray, you've set this up perfectly for me. I've
Hey.
been pursuing you to speak to me because I know you have the data science background, but I always call you a data science developer because you've created something that not every data scientist does. So can you tell us what it is you've built, please?
Yeah, so I've built a Python package called PyRetailScience, and you can think of it essentially as a collection of retail analytics code that allows you to really kind of quickly and easily run retail analytics analysis on your transactional data. It's still in the kind of the early years, but how I got started with this was I got really frustrated that I would often start off with one client and I would look and I would build some piece of code and then they'd use it, they'd do some analysis. Then I'd go to the next client and then I'd rebuild the exact same piece of code, but for them. And then they'd use it and then I go to the next client and I rebuilt the exact same piece of code. And they're just, even though you have things like scikit-learn, which has some very advanced like regressions and everything like this in there, there didn't really seem to be much in the retail analytics space. I think this might be by design because you can sell the same piece of work to client after client after client. But the developer kind of side of me, there's a concept in computer science called dry, don't repeat yourself. And this work was just a complete violation of that because you're just repeating yourself again and again. And also, it just meant that the bar for the analysis that I was doing, it was never being raised. It was about bringing the retailer up to the existing level, but it was never really about doing even better work. So this Python package is really meant to try and provide like a foundation for retail analytics for retailers, such that it's kind of like this is a level that every retailer should be at if you're doing data science work. And then from there, we can kind of move the bar ahead. Yeah.
Thanks, Murray. And look, thanks for the myth busting part of that. Everyone thinks the data science world and AI and machine learning is super sexy. But it's often about kind of, I don't know, bringing along some code that you've slowly worked on through your life, changing it to fit that client, struggling because there's a missing column, cursing your life. And there's a presentation, which is the exciting part of something happens at the end. So look, well done for building this. And so everyone knows, Python package means everyone has this software on their machine and you're kind of downloading Murray's package to your system and then it's all available to you. So it's this is how the package side of it is working. Murray, why not let's pick on something like one of the let's start on the number first of all. So this thing allows you to do retail analytics. How many analyses are in this package? Like if you were a retailer that, let's say you got transactional data, you might not have an analyst there or many, and you might not get much analytics. What do I get like out of the box when I install PyRetailScience?
So there's a number of kind of modules that are part of it. Some are on the simpler side, and what they're really meant to do is provide kind of presentation ready graphics that you can put right into your PowerPoint. Because one of the parts I really disliked about doing a lot of this analysis in Python is that you ask it for a chart, and it just gives you something so horrendously ugly that you can never put in front of a stakeholder. So I'd write like, 2 lines of code to get the chart, and then about 30 lines of code below it to, use a nice font, use colors well, standardize, the axes and that. So that if you go from like that level of stuff all the way up to the more advanced stuff like gains loss analysis, there's about 15 to 20. And we're kind of always adding things and improving the speed. And I use it like almost every single day. So it's under quite active development. Yeah.
Good. Let's pick on a specific one if it's okay. So there's 15 to 20 in there. We can either pick on the first, or your favorite, or the most popular when you show it to a client. Which retail thing can we pick on? What does it do?
I would probably pick on the revenue tree, or the KPI tree, as it's sometimes also known. What it does is it allows you to see where your change in revenue between 2 periods, like what's driving that. Is it an increase in customers? Are customers spending more per transaction? Are they coming more often? Are they putting more in their basket? Are they putting more expensive things in the basket or less expensive things? And so sometimes when you're working with a retailer, they'll just see the revenue's dropped, and they won't quite be sure why. And so the revenue tree really allows you to kind of clearly break down what is driving that, up or down. And it's, I think, one of these things that's very intuitive once you kind of see it and understand it, can have a really big impact, and isn't kind of like, and isn't incredibly complicated to kind of understand and see behind the scenes. Yeah.
So this is like a decomposition of, like, as things change between 2 periods, the retailer just sees, I lost $1 million week on week or something like this, and you're able to say, actually, we had more customers but with smaller baskets, therefore
Exactly.
this happened, something like this.
Yeah, because the kind of the traditional thing is you just see like an Excel, and there's just a whole bunch of numbers, period 1, period 2, units, transactions, customers, da da da, and you see some going up, some going down. But really, what is driving that? And then we can also add revenue contribution. So if your units decreased from an average of 2.2 to 2.1, does that mean 1 million, 100 million, a billion euros, pounds, dollars lost? So the revenue tree really helps you understand that. And so you can kind of connect that directly back to your revenue change. Yeah.
And so I see the outputs then, like WYSI outputs that help you have insights into trading and customers and these things. Let's go just back to the inputs for this. So you've got 15 to 20 canned pieces of analytics in the package. Can they all operate off of the same input, or are there slight variants? And can you describe the input? So if someone's watching this that's at a retail brand thinking, I don't get much insight here, what are they? What kind of is the input data that they would need to have to kind of get most of the benefits from this?
Yeah, so it's transactional data, and there's more working on the package, but the idea is that based on whether you have only transaction level or you have item level data, you can essentially put that into the functions, and then it will kind of say, well, you have this data but not that data, so I can display only these stats. But if you gave me which product IDs, then I could display units per customer and other things like this. So that's what it is in a nutshell. But one of the real powers of the package is that it can take the output of one function or one module and use that as an input for another. So for instance, you can break your customers out by some segmentation on how they spend. So heavy, medium, light is a classic kind of like a simple customer segmentation. And then you can run follow-on analysis on that. So if you wanted to do break down your customers by how much they spend and see one kind of revenue tree for each of those, you can run the heavy, medium, light segmentation. For each customer, you'll get what segment they're in, and then you can run the next piece of code filtered onto only heavy customers, only medium or light customers. And so you can really start chaining analysis together in a way that is very difficult to do with a dashboarding system. And so the package hides a lot of the complexity of these things and the calculations and all the inevitable little bugs that creep in when you name a column wrong or something like this. Yeah, and so you could, it ends up mixing and matching in ways that I don't know. I've used dashboarding systems before, and you run a report for somebody, you take the screenshot, you copy the data out, you put it in Excel, and somebody says, "Oh, that's great. You do this 50 more times for 3 different time periods," and you're like, 150 reports. Now I just write that into a list in the software. I click go, I go get a coffee, and 15 minutes later I come back and it's like, oh, here's everything you need. Yeah. So it
Yeah,
really unlocks a lot of value.
I was really reflecting on this. Without the package, I am that guy, Murray. So I'm probably not as good a coder as you. I'm the guy that I get to first base very quickly, so I can almost produce any piece of analytics ever. First base is like, here it is. But for folk who don't code, first base can easily be 1,000 lines of code that get you to this point of here's my first output. And invariably, it's like, can we just divide this by 42? What is it like when we profile by women? Can you subset these stores? And so I really see the benefit of chaining the functions like this. Murray, give us an insight as to just how it was building this thing. 2 insights I'd like. Can you give us an insight as to like what you enjoyed the most, and then what's nearly made you cry? Tell us something bad about this, because it all sounds so awesome.
Well, the awesome piece is like once you put in the effort to actually code it up and everything, when you're able to deliver insights so quickly that people are like, "You're done already," and you're just getting things done, and people are asking like, "How is it possible you got it done so quickly?" That's really nice, and I'm able to do just a lot more work. Like I think at least for the things it does, it at least doubles my productivity, and that just makes the work I do like more valuable, and I can serve a lot more customers, and the ROI of data science functions, it's just so much higher. The downside is the actually the coding of it, because one of the benefits where you rewrite the same thing again and again and again for every client is that you make it kind of bespoke to them. And so there's a bit of an expectation that it's bespoke. But adding in that kind of flexibility so I'll think, well, I had this piece of analysis, but this company wanted it this way. That other company wanted this slight change. That third company said they didn't like the first thing that the first company did. They wanted something else. And then trying to cover all that in one piece of code, it ends up being kind of challenging to say, well, I'll wait on putting that bit of functionality in, even though I know it's needed, because it adds a lot of complexity. And so you end up having to do a lot of kind of I don't know, mental gymnastics sometimes to get it to where you want it without spending hundreds and hundreds and hundreds of hours on it. Yeah.
Yeah, I suppose you have a conflict between trying to coach. Do you change the input so that it fits everything, or do you allow the package to change so that you handle the edge cases via a parameter or something, like if something were missing or different, or I don't know what you kind of change the control you have over the function.
Yeah, it ends up being what do you put in and what do you leave out? Yeah, that ends up being the most challenging thing, because if I had my way, I'd probably put everything in, because you end up in these situations again, and it's just like something that would actually be a lot of work and a lot of recoding and a lot of copy pasting. You just set it to false, and now all that functionality is skipped, and you get exactly the results you want. But to have that thing where true false actually means something to the code, that can take a lot of work.
Well, Murray, congrats on what you've built. Thank you for joining me. We've hit time. So thanks for all your insights into that. What I like the most, so 15 to 20 pieces of retail analytics installed simply on an analyst's machine with 2x productivity as the potential. So I like all of those numbers, Murray. So thanks for your insights today. Ladies and gents, this has been ML's Like Teen Spirit.